A solid cube has the same volume as a square pyramid whose base has side length 9 cm and height 8 cm. What is the edge length of the cube? Okay, um, we have a cube and a pyramid in this question. We don't know much about the cube, but we know more about the pyramid. We are told the side of its base, and its base is actually a square, and as well as its height. But we need to know about the cube, and the only way we can do that is by studying the pyramid and then use that information on the cube because we are told they have same volume, exactly same volume. All right. So this is it. We have to understand how pyramids work and then um, relate that to cube. A cube is actually a prism. So let's take a look at the pictures here. By the left, we have 3D shapes with a pointed top. You know those ancient Egypt structures, those ancient Egyptian structures, they were called pyramids of Egypt. Okay, you see, they all have one sharp vertex at the top. Okay, that should help us understand why the structures are called pyramids. Okay, and these other ones here, you see, they do not have any sharp vertex at the top. What you're seeing here is not a vertex. You have a triangle as the base, you also have a triangle at the top. You have a four-sided shape, in this case a square at the top, same thing at the base. Circle up, circle down. Whatever at the top, same as the down, these are prisms. Okay, another way of seeing this is prisms. The sides, the faces of prisms are always four-cornered. So this face facing us right now is 1, 2, 3, 4. Now there's another face to the right. That's 1. That face 1, 2, 3, 4. 4 sides. This one 1, 2, 3, 4. Same as this 1, 2, 3, 4. Just like that. And based on this second logic of having 4 faces, let's compare that, 4 sides on each face. Let's compare that to pyramids. They're just about 3 sides, triangles, triangles. So all the faces of pyramids are triangular. And for that reason, we cannot completely classify these last two as pyramids or prisms. But they are here because the logic, because we're about to study volume, the logic for volume works on them. The logic for volume of prisms and pyramids work. Now, what's the logic? We need to know the volume of a pyramid. This kind of pyramid here does not have a square base. So let's think of a square based pyramid. Okay, because a pyramid, there will just be one point up here, and this will be connected to this vertex, this vertex, this vertex, and that vertex. So it's connected to the 4 vertices down there. Now, because it's a square and the side length is 9, so we're having 9, 9. Remember, I want to get its volume and then use that to figure out the volume of a cube. Now, what is a cube? A cube is actually a prism, but made of squares. So we have a square and another square. So connect them with lines that are equal to the length of the sides of the square, something like this. So when all the lines are the same, are equal, we call that um, a cube. So this right here is a cube, and the sides of the cube are all equal, but we do not know what the sides are. All right. Now, how to calculate for the volume of prisms and pyramid? For prisms, you just figure out the area of the base area. Okay. When you figure out the base area, you multiply that by height. So the area of the base here, because this is a triangle, the base area here is half base times height. So if this is your base, you look for half of this length multiplied by height. So your height would be this way because this is your base. If this is your base, if this is your base, you look for half of this base and multiply by height. Now your height will be this way, just like that. However you want to do it, half base times height. Now, you now multiply that to another height, which in this case is the height of the entire 3D shape, the height of the prism. So I'll use a capital H. For this, length times breadth, because it's a rectangle, these are cuboids. So length times breadth gives us the area of the base. Multiply that to the height, okay, times the big H. Here, the area of a circle is pi r squared, and then we'll multiply to height. Now, if we want to find the volumes of pyramids from this, all we need to do is divide by 3. The idea is if you assume that this prism here and this pyramid here have exactly the same base area, that is to say the area of this triangle right here and the area of this other triangle right here are perfectly the same. If you assume that, and then the heights are also this height right here and this height are both perfectly the same, it then means whatever you get as the volume here divided by 3 gives you this. The same thing here. If these base areas are the same, if they are the same and the heights are the same, just like that. So whatever you have as the volume formula for prisms, just multiply by 1/3 or divide by 3, the same thing. So it also works between cones, this is a cone, and cylinders. So you divide the value you got for the cylinder by 3, provided the base area and the height are the same, you get that of cone. So that just works as the formula for pyramids. All right. Having known that, we'll have a square pyramid, 9 by 9. Base area is 9 cm as given here by 9 cm, right? Good. And that is 81 cm squared. Having gotten that, we proceed to figure out the volume now. We multiply by height and of course divide by 3. So 81 times the height is 8. And then we'll divide by 3. Good. After doing that, we'll get 216. This time around cm cube, because this has a cm cube and this has a cm squared and this has cm, so cm cube. Now we have the volume of the pyramid. We can just go ahead and use that as the volume of the cube in this particular question because we were told they're the same. All right, we're told they are the same. So let's go ahead and use it. But before then, what should have been the formula for finding the area of this cube? Normally, the formula should be like every other prism: base length times breadth times breadth times height. I'm going to use a big H here as usual. Okay, so length times breadth, we do not know, but we know because it's a cube, the length will be equal to the breadth. So it will be length times length times length, because the height will also have to be equal to the length. So it's actually L cubed. This is the volume of that cube up there. Okay, so this right here, after calculation, should be equal to this here because they are the same. 216. Let's go ahead and find L. We find the cube root of both sides, and then we have this 2 1 6. That's the cube root. All right. Now the cube root of 216 is 6 cm.